Okay, so my name is Michael Puntorno. When I wrote this, I was working at Headland Archaeology, which is part of the RSK Group. But as of the start of this month, I have moved over to the RSK Geophysics department, doing utility surveys for their safe ground department. So I spent 6 months doing archaeology surveys, where I came up with the idea for understanding the impact of what is needed to lay a water pipe or any large pipe across a long landscape in relation to the archaeology that is needed. So, the need to evaluate large linear corridors traversing many kilometres of often the countryside in advance of building such infrastructure as pipelines or upgrading of existing routes continues to create considerable demand for the assessment of potential archaeology along these routes. Linear developments are complicated, but by the large and extended area of land affected due to changing archaeological needs, geological and soil conditions through these routes, and as well dealing with the complexities of multiple landowners, which can always be an issue. So if you're laying a long pipeline, obviously you will change geological need boundaries. So obviously the needs to be able to lay this pipe is much different from one end of the pipeline to the next. And obviously with changing cultures that have evolved in this country over the years, the archaeology will be different as you pass through more rural areas to more built-up areas. Geophysical surveys play a crucial role due to the variety of non-invasive surveys that can be used to assess the possible archaeological remains that are there. And it's important to get know what you want before anything goes ahead. So the earlier in the planning process, the better. It is important to cover as much of your area as possible to know what archaeological potential will be in your area, but also to be aware of the geologies and soil types that may affect the type of geophysical survey that will be needed, as geologies and soils can mask archaeological features in relation to what you're going to be doing over these areas. While it is important to implement a geophysical survey for the initial development, it's also important to consider obtaining geophysical survey in the future in and around these pipelines. So I know many a time we're using polyethylene pipes, but for the larger ferrous pipelines, obtaining geophysical data around these will create a huge disturbance up to 20 meters either side of this pipeline, which will make it nearly impossible to collect any meaningful magnetic or electromagnetic data either side. So if there needs to be improvements or anything like that to the pipeline, it's extremely difficult to do so. So a balance must be met between the cost of obtaining the initial geophysical data and the possibility of anything that may be needed to be done in the future. So a slightly larger initial corridor for this pipeline would be better to collect slightly more data initially to save money in the future. Okay, so sometimes archaeology and archaeologists are seen as causing unnecessary delays in construction and development, and archaeology is not actually one of the main reasons for delaying construction or development projects. So I've put some information up here, which has been come from a archaeological group that shows that archaeology actually benefits the construction industry and actually aids in saving money in the long run if a proper plan is put in place initially. So geophysical techniques. There are a number of techniques that can be used in assessing potential archaeology along a route of a pipeline, the most common being magnetometry, so magnetics, and electromagnetic surveys. These two techniques are the quickest. You can survey large areas quite quickly. When I was with Headland, when we were doing magnetic surveys, we were collecting anything from, in very good conditions, obviously, around 8 to 11 hectares a day, or between a team of 2 guys and 1 frame. Obviously, that's on nice flat grounds, but yeah, and other techniques can also be used in supplement to these techniques, so resistivity mapping and ground penetrating radar. These will be used to gain more information. So if you've already done a magnetometry survey and you found certain features that could be enhanced in the data by resistivity mapping or radar, then these can be employed. And this is where how the soils and geology can affect either the magnetometry. You can therefore employ resistivity to help bring out any features that are already in the ground. So magnetometry, the picture on the right is one of the frames that we were using at Headland. There's many different adaptations of a magnetometer. There's basic H frame, which only has 2 sensors. This one, which has 4. There are carted versions that have 8 sensors, and it's all about how much detail you are collecting with your cart. So generally, the more sensors, the more information you can get with the frame. For magnetometer, anomalies are produced when very features exhibit different magnetic properties to the surrounding soil. So features such as kilns, hearths, or furnaces may be detected due to the burning process has altered the iron minerals. So therefore, you get a strong magnetic response. But then also, such items as ditches and pits can be located due to being silted up with more magnetic soils, or the changing in orientation of how the soil particles, their magnetic field has changed. Though if, for example, a ditch has been filled in with exactly the same soil as that around it, you may not be able to see it as well as you should. So that's where, for example, resistivity would come in to help enhance that feature. Electromagnetics, so this I'm using the CMD Explorer as an example here. It's a quick method of data collection, and the advantage of the CMD Explorer is it can provide a wide range of information as a tool. So the CMD Explorer is an instrument which has 3 separate receiver coil separations, which can provide magnetic susceptibility and conductivity readings from these 3 different dipoles, thus therefore providing 3 separate depth penetrations. So if you've got quite deep features, you can actually visually see features going from ground level down to approximately 6.7 meters in depth, which you can, so like I said, if you're analysing data, you can slowly see the shape of a very deep ditch or other features. And the benefit here with some clever processing, you can actually process the conductivity, which is the inverse of resistivity, and you can actually analyze the data in a different way. So with resistivity, this is a very the design of this has not changed very much over many years. This is a setup of a setting of Venn array, and it involves putting a small electrical current into the ground through electrodes, and is influenced by soil moisture. So, for example, ditches filled with moist, water-retentive soil will always have a lower resistance to the surrounding area. So, therefore, whereas magnetics obviously deals with the magnetic influence of the soil itself, if there's not much difference between what's being filled in the ditch and the surrounding soil, then resistivity may help enhance that. But once again, this is quite a slow method of data collection, and should only really be used as a targeting in on areas that you picked up with either magnetics or electromagnetics. And then GPR, ground penetrating radar, is a great method of gaining additional data. It sends a short pulse of radio frequency energy into the ground and records the time and amplitude of the reflections back off those remains. It can be used over a wide range of surfaces, like for example, seeing through tarmac roads, concrete, to reveal underlying archaeology, where magnetometry wouldn't be able to do. This would. And once again, on a pipeline survey, GPR could either be used to detect a pipe that's already in there quite well, especially if it's a polyethylene pipe. Would not necessarily see the pipe, it would see the ditch cut or where it is. Then for archaeological features, this is great for 3D modelling of features along a pipeline. So archaeology may only form a small proportion of a wider project, but can cause serious problems for schemes where it is not considered properly in the early planning stages. An integrated archaeological geophysics approach should be considered in the planning process. The area covered by detailed geophysics should be sufficient to encompass as much of the development area as possible, and any additional areas where damage to underlying archaeological deposits may occur. So if you're going to plan access routes for plant to put a pipeline in the ground, then all areas should really be covered. A balance must be met between cost of obtaining adequate geophysical coverage for the impact of the proposed development and the need for any future works. So having a wide enough area covered. The width of the corridor to be evaluated using geophysics will depend on the particular linear development. A linear corridor with a minimum width of at least 50 meters should be implemented to include any additional developments. So obviously taking into account that big metal pipe will have 20 meters either side of it, so that's about 40 meters, and then so coming out an extra 5 meters either side on that, so approximately 50 meters should be able to give you enough information along a pipeline. But then if you think there's going to be areas where you're going to have a different additional infrastructure to deal with the pipe monitoring stations, for example, possibly having a wider area covered would benefit this, because so you already have that information there ready for you in the future. So by using a method of more rapid data collection such as magnetometry or electromagnetics to rapidly cover the survey area, an informative plan of the archaeology in the survey can be acquired. Then using a more targeted approach with other methods such as resistivity to bring clarity to more subtle features in the magnetics or the electromagnetic data can provide a greater picture of the archaeology. By spending more time undertaking a more detailed geophysics survey, this can save time and money further down the line. And if further archaeological works are required, as a more informed, targeted approach can be undertaken to deal with trenching if required, or watch and brief. So if anything is found, an archaeological company will be able to deal with like where to put trenches easier and have more information on how to implement that. So we'll hopefully save money in that aspect of the pipeline. And by having a strong archaeological survey in place, then the findings can also be presented to the public, to universities, to help learning and help get possible public interest into such infrastructure projects, which is, for example, HS2, obviously the nightmare of HS2 that goes on. The archaeology is massive across that project, although not a pipeline, obviously. But a lot of the time, like, geophysics is not shared to the public and made available to universities. So you may find some amazing examples of Roman forts, for example, but that data is never shared out. You only find, archaeological reports in grey literature years down the line. So yeah, that's the end of my presentation. Is there any questions?